In chemistry, one of the most important aspects is measurement, which is the search for exact and variable standards. The current universally accepted measurement system is SI units, from the French Système International des Units. There are several base units which are used for exact measurements, such as length being measured in meters, but there are also derived units which use combinations of 2 or more units and are useful as conversion factors. An important one is density, which is the mass of an object divided by its volume. Another frequent measurement in chemistry is temperature, which is a measure of how hot or cold an object is relative to another, which uses the base unit Kelvin. Substances have both extensive and intensive properties. Extensive properties, such as mass and volume, are dependent on the amount of substance, while intensive properties, such as density and temperature, are not dependent on the amount. Atoms are electrically neutral, spherical entities composed of positive charged central nuclei that are surrounded by 1 or more negative charged electrons that move rapidly within a available volume and are held by the attraction of the nucleus, which consists of protons with a positive charge and neutrons with no charge. The atomic number of an element is the number of protons in the nucleus. The mass number is the total number of protons and neutrons in the nucleus. Isotopes are atoms of an element that have different number of neutrons and therefore different mass numbers. The isotopic compositions of elements are determined by mass spectrometry, which are the atomic mass, the average mass of its naturally occurring isotopes can be figured out.
So chemical reactions can be represented in the form of equations, mathematically expressing dynamics between the compounds and elements involved via ratios that are worked with a quantity of moles. The reactants are substances present before chemical change has occurred, and the products are the substances produced after the change has occurred, which both have their physical forms declared as solids, liquids, gases, or aqueous solutions. A chemical equation is a statement that uses formulas to express the identities and quantities of substances in a chemical or physical change, and must be balanced by having the same number of atoms on both sides. The process of balancing entails multiple components, translating the statement into an equation, balancing the atoms in the equation, adjusting the coefficients, confirming the balance, and declaring the states for each reactant and product. The oxidation reduction or redox reaction is a specific type of chemical reaction that results in the overall movement of electrons from one reactant to another. This scenario occurs when a reactant with a weak attraction to its electrons, a reducing agent, loses said electrons to the reactant with the stronger attraction, an oxidizing agent. This process occurs in both ionic and covalent bonds. Oxidation numbers allow us to observe the state of a compound in an oxidation reaction. This number only notes the charge the atom would have should it experience a complete transfer of electrons, rather than share them. In other words, only ionic bonds are observed with oxidation numbers, rather than covalent bonds. Oxidation numbers follow a few basic rules. All atoms in their elemental form have a value of 0. All monatomic ions will have an oxidation number matching their ionic charge. Molecules should have a net charge of 0, whereas polyatomic ions will simply have an oxidation number matching their ionic charge.
The kinetic molecular theory, the model accounting for macroscopic gas behavior at individual particle level, is based on 3 postulates of 1. The gas is a collection of individual particles with empty space between them. 2. These particles are in a constant, random, straight-line motion, except during collisions. And 3. Those collisions are elastic. The colliding molecules exchange but do not lose any energy. At any given temperature, all gases have the same average kinetic energy. Pressure is due to the countless collisions of gas molecules over the inner surface of their container, with more frequent collisions resulting in greater pressure. Boyle's law states that the pressure exerted by the gas equals the pressure exerted on the gas. Dalton's law of partial pressure states that increasing the amount of particles increases the pressure due to the raised number of collisions by the added particles. Charles's law says that the external pressure equals the pressure of the gas, which is directly affected by the heating and cooling of the sample. Avogadro's law says that the volume of a gas depends on the number of moles or particles in the sample. Graham's law of effusion says the rate of effusion of a gas is inversely proportional to the square root of its molar mass. Ionization energy is the energy required for the complete removal of 1 mole of electrons from 1 mole of gaseous atoms or ions. Electron affinity is the energy change accompanying the addition of 1 mole of electrons to 1 mole of gaseous atoms or ions. Atoms generally bond either ionically, covalently, or metallically. Ionic bonding involves electron transfer. Covalent bonding involves electron sharing, and metallic bonding involves the sharing of valence electrons in a metal pool of electrons that flow between and around each metal ion core. The Lewis electron dot symbol illustrates the valence electrons of interacting atoms to predict how they bond by using the element symbol to represent the nucleus and inner electrons, and dots around the symbol to represent the valence electrons.
Molecular polarity, an uneven distribution of charge, is determined by both the shape and the bond polarity of larger molecules. Dipole movement is a measure of molecular polarity using the unit debye. Its amount can affect macroscopic properties. However, the presence of polar bonds does not always result in a polar molecule, depending on the shape and the atoms surrounding the central atom. Valence bond theory's basic principle is that a covalent bond forms when orbitals of 2 atoms overlap and a pair of electrons occupy the overlap region. The overlap of 2 orbitals means their wave functions are in phase, which increases the amplitude between nuclei. Hybridization is a process of orbital mixing which forms new orbitals, hybrid orbitals, whose spatial orientations match their observed molecular shapes. When 2 electron groups surround the central atoms, we observe a linear shape and refer to it as a sp hybridization, where superscripts indicate the number of atomic orbitals of a given type. sp2 hybridization explains the 2 shapes of possible trigonal planar electron group arrangement. sp3 hybridization accounts for species with a tetrahedral electron group arrangement. sp3d hybridization are shapes due to trigonal bipyramidal electron group arrangement with central atoms from period 3 or higher. And sp3d2 hybridization proposes molecules having octahedral electron group arrangements use 2d orbitals to form hybrids.